look at the definition of a function in the dictionary, you get an activity or purpose natural or intended for a person or thing, such as the function of my coffee cup is to hold my coffee. There's also in that same dictionary a second definition, the mathematical definition, which states that a function is a relationship or expression involving one or more variables. And although this definition is accurate, it's also incomplete. There's plenty of relationships involving one or more variables that do not meet the definition of a function. Kim and Kanye, chocolate and onions, and the Chargers moving to Los Angeles. Now, functions seem difficult for a number of students because it's where we switch from a traditional equation like x plus 1 equals y to the dreaded f of x. People seem really intimidated by the f of x, and I get it. It's daunting and scary because it's new and it has parentheses that you don't use to multiply anything. Once you get past the intimidating parentheses, you can see that the outcome of this function that we are calling f just happens to depend on the value of x. So if we take that function, that same function, f of x, and we equate it to an expression, x plus 1, and then we give x a value such as 3, all that means is that anywhere we see an x in the equation, we replace it with 3. So that function would now be 3 plus 1, which we know equals 4. So therefore, f of 3 equals 4. All it means is if we replace x with a number in the equation, then we solve the equation. That's really all there is to it. Mind-blowing, right? So now you can see that this function, f of x equals x plus 1, has at least one variable, in this case, x, and it has a relationship, which in math basically means that we did something to it. In this case, we added 1. That's what we did to it. So it meets our dictionary definition. But as I mentioned earlier, that definition is not complete. A mathematical function actually has 3 components. An input, which is whatever we put in for x. So going back to the other problem, our input would be 3. The second component is the relationship. In this case, it was x plus 1. So when we substitute in the 3, the relationship is 3 plus 1. And then the third component is the output, which is 4. This is why functions are considered input-output machines, but they still must adhere to a few simple rules.
Good men don't need rules.
Well, maybe if you're a Time Lord you don't need rules, but functions are not Time Lords. The 2 most basic rules are, the first one is that for every input, there's only one output. That means that if there's more than one possible solution, it's not a function. The second is that it has to pass a vertical line test. Now, a vertical line test is a pretty basic thing. It means that if I graph this function, let's say it looks like that. There's my y-axis, there's my x-axis. And I run a vertical line through it at any point, it will not cross more than one point in the function. So, this graph is a function. This graph is not. It crosses more than one point within the function. Pretty simple. Now I mentioned that functions are considered to be input-output machines, and that's where we tend to see them the most, in machines.
He's pissed. You lied to us.
Okay, so maybe not those kinds of machines. A gas pump is a function machine. If you set the input, $20, and it runs through a relation, in this case price per gallon, which we'll call $4 to keep the math simple, it will give us an output of 5 gallons of gas. So for any value we put into the machine, it gives us one specific output. If we graph the gas pump function machine, it will pass the vertical line test. So what about, say, a slot machine? A slot machine has an input and an output, but it's definitely not a function machine. Although most are regulated by the amount they have to pay out percentage-wise, there's really no direct correlation from the input to the output, and a $20 input could have a variety of different outputs. When I'm playing, usually 0, breaking the first rule of functions, that an input can only have one output. So cars in and of themselves are not functions, but they perform a very specific function. The same one we perform when we fly or ride a bike or sit on the couch. They perform the function of speed. Speed is a function of rate and time, and its output is distance. So if I were to travel a fixed rate of, say, 20 miles per hour for a certain period of time, my input, say 2 hours, I would have traveled 40 miles. And the graph would look similar to the gas pump graph, passing the vertical line test. So what about my puppy Atticus? He's most definitely an input-output machine, and I will spare you any images of the output. But is he a function? Now someone might be able to argue that yes he is, because what you put in, you get out in puppy energy and, well, poop. And the whole physics thing about conservation of energy. Well, I'm sure that his input-output do follow the laws of physics. His poop to energy ratios are inconsistent, and therefore Atticus is not a function. And if you graphed him, he'd probably look a lot like this. So there you have it. That's the very basics of functions. Tune in next time. We'll talk a little more about functions and a dude named Fibonacci.